What is up, guys? Fi here and back at it again with another Unreal Engine tutorial, this time a C++ one. Yes, because a lot of you do C++. Okay, I'm going to do a C++ tutorial. Anyways, let us take a look at the game that we are going to create. So over here, I have my editor. If I hit the play button, it's a simple side scroller game. So if I, jump and all of that stuff, you see we can jump, we can move. The goal is to avoid this wall that is chasing us, because if it touches us, we're going to die. And of course, we're going to have obstacles along the way, such as these platforms, such as the spikes that we are hopefully going to see pretty soon, because they are not spawning all of this time. There we go, we have the spikes. If we touch the spikes, bam, we are dead, the level is going to restart. If the wall hits us, bam, we are dead, the level is going to restart. As you can see, it looks like a basic game, but we are going to learn a lot of cool things, especially C++ wise, because we're going to do all of this in C++ from scratch, coding everything, and you're going to see me code, and you're going to enjoy that and learn a lot and yada, yada, yada. Anyways, what else can I say? Let us jump into this course. Yeah, it's a mini course. What else is, it's a mini course, okay? It's tutorial, a mini course, whatever. Let us jump into it and create this cool game. Alrighty then, my game dev elves. Now that we saw the game that we are going to create, let us create the game. So over here, I have the Unreal Engine project browser. We are going to click here on games. And by the way, this is Unreal Engine version 4.25. And we are going to select our third person project. So not the blank one, but the third person, because we need some elements from that, third person package. And over here, we're going to click on next, and from blueprint, I'm going to click on the drop down list and select C++, because yay, this is a C++ course. And over here, I'm going to name my project. I'm going to call it Side Runner CPP. Of course, you can think of something more creative than that. I'm going to click here, create project, and wait until the project is created, and then I am going to come back. And here we are, finally. So now what we are going to do is we are going to create the player, and specifically the player class. Over here, by the way, I have this engine content. We will use that as well. If you don't have it, you're going to click here where it says view options. So this right here that I draw. So click on that, and from there, you're going to click this checkbox, show engine content. So make sure that that is checked, and then you will be able to see what I see in my project. Also, one neat trick: if you find that all of these elements inside of the editor are too small, especially if you have a big monitor, you can go over here under window and then developer tools, and then you can go over here widget reflector, and let me just bring that bad boy over here, and this is the scale for the application. Usually I set it at 1.16, and it is going to rescale my application, basically make it a little bit larger and that stuff, so that I can see more better. That's all there is to it. Anyways, going over here in the content, I'm going to right click and create a new folder that I am going to call maps, because over here we're going to create a new map, and that is going to happen under file and then new level. Basically new level, I said map, but that's the same thing. Control S to save it. I'm going to save it over here, and I am going to call this one gameplay. And there you go. So the first thing that I'm going to do with this gameplay is I'm going to remove the floor that we have over here. So simply delete it, and there you go. And next I'm going to go here into geometry and meshes, and I'm going to take this template floor and place it over here, and there you go. Let me just position this bad boy. So for the X is going to be 0, for the Y is going to be 0, Z is going to be 20, and I am also going to rescale it. So I'm going to click here on this lock icon to lock the scale, and I'm going to say 0.25, and there you go, rescale it, and voila. Also, in regards to the player start position, let me just click on that. Yeah, it is going to be where it is, and this is where we are going to spawn our player. Now, before we proceed to create the player class, over here inside of the project settings and in the input, we are going to have some mappings and axes. So basically we only need the jump. So I'm going to delete this reset VR. Simply click here on this X and delete it. Here we are going to have move right. We're not going to have move forward and all of these stuff. So look up, look rate, turn rate, and move forward. We're going to delete all of these and leave only all of these. Of course, you can also filter these. So we don't need the gamepad. I basically only need the space bar. But again, that is up to you, depending on if you want to create, maybe you want to practice or whatnot. I don't know. I'm not you. I'm not, I'm not controlling you and stuff like that. So there you go. So we should have jump and move right. For the jump, we have the space bar. For the move right, A and D. You can also add the left and right. That is totally up to you. I am not going to go in there, do not judge me. So now we can go over here inside of our C++, so C++ classes, and from there you go. Here we have our SideRunner CPP character. I am not going to use that one. I'm simply going to right click and go here, new C++ class. It is going to inherit from the character. I'm going to click on next, and I am going to call this one runner character and hit the create class. Of course, you know that it takes a while for Unreal Engine to, compile and load all of this. I am going to get an M2 SSD just because of this. Like, I'm not kidding. Just because of this, I'm getting an M2 SSD that can read for, I believe, 3,500 megabytes per second. So that is what I'm getting, okay? This is what I'm going to get. And finally, here is my class. So we have the runner.h file and the runner.cpp file. If you don't know the difference between the two, I'm quickly going to explain. So in the .h file, we declare everything that we need, and inside of our .cpp file, we then code all of that we have declared. Simple? Yes, it is. So what do we need? Over here, right below where it says our generated body, I am going to declare a uProperty. So it's property. There you go. Sometimes I cannot spell, and I'm going to call it visible anywhere. There you go. And this one is going to be our class. This is called a forward declaration when you type a class, so that we don't have to include the file over here. And I'm going to say uCamera component, and it's a pointer, so we need to denote that with the star. And I'm going to call this one side view camera. Now, as I said, this is called a forward declaration, I believe. I'm not 100% sure because I'm not good with those names. I don't care. But essentially, what is the point of this is that we declare it with a class over here so that we don't have to use the include over here. You see, because every single thing that we use, for example, if we want to use functions from the character, we need to include the game framework character. But I don't want to do that for the camera component, because every time you include the runner.h file anywhere in your class or in any other class, that is, then it will include all the includes that come with it. But when you use it like this, then it will not include them. But inside of here, runner character.cpp, then we are going to include it, and that is the better way to go. So over here, this is, the constructor for our character, the begin play, and all of the good stuff. Tick and set up player input component. So we are not going to touch any of those. Instead, what I'm going to do is over here, protect it. And over here, I'm going to declare my own functions and variables. First things first, I am going to declare here void move right, and this one is going to take a float value as a parameter. And of course, in a moment or two, it is going to start complaining with a green line below this move right because we didn't declare it inside of the .cpp file. Don't worry about that. We will do it in a few moments. So over here, we're also going to create a public, and this one is going to return our uCamera component. And again, it is a pointer, and I'm going to call this one get side view. So get side view camera component. And this one is going to take a constant, or actually it's a constant, and it is going to return the side view camera. Simple as that. Next, we are going to have another public function that I'm going to call void restart level. This is going to happen at the end when our player gets killed, which is something that we saw as well. Also, what I'm going to create, and this is what I said, it's going to complain with this. Don't worry, we will implement this in a few. Over here, I'm going to create a u function, and this one is going to be our void on overlap begin. It's going to take a u primitive, so primitive component, which is a pointer, and I'm going to call this one overlapped component, comma, it also takes an a actor, or simply an actor, but it's spelled a actor. It's a pointer, and I'm going to call this one other actor. There you go. We're also going to take another primitive component. So I'm going to copy this here and paste it, and it's a pointer. So again, we need to use a star over here. And other comp or other component is I'm going to call it. It takes an int32 other body index, a boolean b from sweep, and last but not least, a constant of f hit result, and over here sweep result. There you go. And last but not least, a few more private variables. One is going to be the z position, so float z position. There you go, it's position, like that. We are also going to take an f vector, which is going to be our temporary position, that I'm going to denote is equal to f vector, like that. And last but not least, a boolean to denote if we can move or if we cannot move. Now, of course, over here, as you can see, it is complaining for the move right and the restart level. It is not complaining for the on overlap begin, but it will start complaining because I'm still waiting for that SSD to come. So what we need to do is we need to declare this function over here inside of our runner character.cpp file. So we need to, as I said, declare it, and that can happen by going over here and declaring and typing it, void a runner character, colon, and so on and so forth. But there is a quicker way to do this. What we can do is we can click on this move right, and I can right click, and then I can go here, quick actions and refactoring. And over here, I can say create declaration definition. And there you go. When I click on that, it is going to create it. Of course, this HDD drive, it's driving me nuts. And I will probably have to cut out this video because, if I sing to you, that will cost you extra. I mean, this is on YouTube. You don't pay anything for this. But there you go. Finally. Okay, so now if I go here in the runner, there you go. So we have the void runner move right. We can do the same thing for this over here. So we can, do the same thing for the restart level by typing void a runner character, colon, move right. But instead of that, I'm simply going to right click again, quick actions and refactoring, and I'm going to create a definition for it. And last but not least, we need to do that for on overlap begin. So quick actions, refactoring, create declaration. There you go. Save this over here, and voila, here are the functions that we need. So from here, there you go. So what are we going to do when it comes to our runner character? Well, for our runner character, here is where I said that we are going to add those includes. So first one, I'm going to include, and that one's going to be components. There you go. It's components and then backslash. And this one is going to be capsule component.h. And I'm going to include everything that we are going to use. So over here, we're also going to include, in quotes, game framework, and then backslash spring. Actually, we don't need the spring arm component. We need a camera. So I got carried away. Usually when you use the camera, you use the spring arm, but I'm simply going to use the camera without it. So camera dash or backslash camera component dot h. There you go. And also include, and over here, game framework. So game framework. Actually, yeah, it's capital framework, like that. And backslash character movement component, and there you go, actually .h, and now there you go. So this is these are the includes that I was talking about when I forward declare the camera component. So instead of using this camera component include over here, I'm simply going to forward declare it like this, and then over here I'm going to use the include, because if we need to use the runner character in some other class and we need to include the runner character.h file, when we include that, it will not include this import because this import is inside of the .cpp file. So over here inside of our runner character, which is the constructor, basically what we are going to do, first we're going to set the capsule component. So I'm going to say get capsule component, and from there I'm going to say init capsule size, and the size is going to be 42 on the X and 96 on the Y. There you go. I'm also going to set the channel to respond to collision with overlap, basically setting the collision settings to response with overlap. So over here, I'm going to say get capsule component. So get capsule component. There you go. And over here, I'm going to say set collision response to channel. And from here, going down, I'm going to say ECC underscore game trace channel. And it's going to be trace channel 1. And I'm going to say ACR overlap. There you go. And moving forward, we are going to denote that we are not going to allow the controller to rotate us. Instead, we are going to use our own, or basically we're going to control this class from within itself. So I'm going to say here, B use control rotation pitch. That is going to be equal to false. I am also going to simply copy this and paste it. And this one is going to be pitch. Then we're going to have the roll. And last but not least, we're going to have the yaw. Basically, as I said, this is not going to allow the controller to rotate. The controller is not going to rotate this character. Instead, we are going to do that from within this class. And since this is a side scroller, we're not going to rotate at all. Next, I'm going to create the camera. So our side view camera is going to be equal to create default sub object, and it's going to be type of view camera component like that. And I'm going to give it a name by passing here a text. And that name is going to be side view camera. Simple as that. There you go. Nothing, complicated. I'm also going to, or I don't want the controller to rotate the camera as well. So I'm going to say side view camera. And over here, I'm going to say B use pawn control rotation. That is going to be false. So this is not going to allow the controller to rotate the camera. Next, I'm going to set the character movement to face the direction that we are moving to. So if we're moving to the, or in this case, because the game is a side scroller, we can move forward or we can move backwards. So that is why I'm going to say over here, get character movement, and from there I'm going to say B orient rotation. So orient rotation to movement, that is going to be equal to true, which is basically going to allow us, as I said, to rotate towards the direction where we are going. Now this is going to be the rotation rate. So I'm going to say get character movement, but I'm going to copy it because we're going to use it a few times over here, and I'm going to say here rotation rate, and that's going to be equal to F rotator. And over here, I'm going to say 0 for the X, 720 for the Y, and 0.0f for the Z. Now, if somebody is confused, if this is your first time seeing Unreal Engine C++ code, first things first, I am advising you to go through my C++ tutorial series here on YouTube. You'll have that in my academy as well. But what I wanted to say is, if you're confused why I'm using here 0.0, but over here 720 point, and I don't add 0, what is the difference? Well, there isn't actually. So you can add 0, you can omit 0, it's the same exact thing. So that is when it comes to the rotation rate. And I'm going to actually 0.0 here and move this backwards, and there you go. So next we're going to set the gravity scale for our character. So I'm going to say gravity scale, that is going to be equal to 2. I'm also going to set the air control. So air control is going to be equal to 0.f. Air control is basically how much control of our character do we have while he is in the air. The higher the number, the higher the control. Next, we're also going to say here our jump z velocity is going to be equal to 1,000. That's basically going to be, how far or how high we can jump. Next, over here, I'm going to say ground friction is going to be equal to 3. And ground friction is basically, the collision with the player and the ground. Also over here, I'm going to set the max walk speed. That is going to be equal to 600. And last but not least, max fly speed, that is going to be equal to also 600, and there you go. And now we are going to get our temporary position. So I'm going to say temp pose. That is going to be equal to get actor location. which is the current location of our actor or basically the game character. And I need this temporary position because I'm going to say our z position variable is going to be equal to temp position.z plus 300.0. There you go. And now what do we need to do? We need to bind our controls if we want to move the character. So over here we have our setup player input, and this is where we are going to bind the axis and the jumping and all of the good stuff. So now we have this player input component that is passed over here in the setup input component. So I can simply use that, and I can say player input component, which is, called, as you can see, to bind functionality to input. So I'm going to say over here bind action, so bind action, and I'm going to bind the jump action. And how, where, or what? Where do I have this jump action? Well, the jump action is over here. If I go into the project, here it is, action mappings, and this is the jump action. So this name needs to match up with the name over here that we specify. So bind that to, and of course, because this is an action, we can press it and release it. So I'm going to say IE pressed. Basically, what do we want to do when we press the jump button? Well, over here, we're going to bind it, passing this as well. And over here, a character, : jump. There you go. So essentially, when we press the jump button, or in our case, the jump button is denoted with the space bar. So when we press the space bar, we're going to call the jump functionality from the character that we have inherited, because this class inherits from the character. You see here, public a character, and the character has some built-in functionality such as jumping. So I'm also going to copy this, because when we release it, we are going to, so this is IE pressed, and over here IE released. So when we release the jump button, instead of jumping, we're going to stop jumping. This will stop the jumping of the player and he will start to fall down. Simple as that. Next, I'm going to take the player input component, and now I'm going to bind the axes instead of binding the action, and I'm going to bind the move right, and I'm going to bind it to this, referring to this class, and referring to the a runner character : move right. There we go. So this right here is going to bind to the move right, which is, again, going back over here. This is that move right. It is going to bind to our move right function, which is this function over here. So essentially now, over here in our move right, we are going to add the code that is going to move the player. So over here, we're going to test if can move, and we are going to use this to denote if the player can move when he's dead. We will see that later on. But if the player can move, we're going to say add movement input. And from here, I'm going to say f vector. So it's f vector. And over here, 0 movement on the x. On the y, it's going to be 1. And on the y, or actually on the z, it's also going to be 0. And over here, I'm going to pass the value that we have. Now, in order for this to work, we do need to denote inside of our begin play that can move. So can move is going to be equal to true. This is when we start our game, which is, normal and all of the good stuff. Otherwise, it will not work. So I'm going to hold Control Shift and press B. This is going to compile my code. And of course, we're going to wait a few moments. I don't know, maybe I will cut out this video depending on how much it will take, because again, my SSD is still not here. I can also try to sync to you. No. There you go. It worked. You see here, build succeeded, which means now we can go inside of our editor. And if I were to go into the gameplay and hit the play button, we do see a character and we can move the character. But this is not our character. This is the built-in one that we have created with the project. So in order to create our own character, I'm going to right click over here and go into the new folder. I'm going to call those some blueprints. And from here, I'm going to click and go inside of that folder, and I'm going to create a blueprint class, and I'm going to inherit from the runner character. So here is my runner character, and I'm going to click on that one, and I'm going to say BP runner character. So this is now our character. This is going to create our character from the class that we have just created. Of course, as you can see, we don't have anything. We do have the side view camera. You see, we have created it over here. But what we need to do is we need to click on the mesh, and over here we need to add a skeletal mesh, which is basically going to be our mannequin, which is this bad boy over here. I'm also going to set his Z location to -97 to lower him a little bit down, as you can see. And I'm going to rotate him 90 or -90 degrees like that. And basically that would be it. I can compile and save this. Well, one more thing, we do need to attach here a blueprint class for his animation, which again, click on the drop down list and we have the third person anim BP, which automatically will make him or he will be animated. Now, in order for us to add our character right now in the game, we need to create our own game mode, because if you remember from the previous tutorial, previous Unreal Engine tutorial series, over here inside of the maps and modes, you see, we need to create our own game mode, because currently, again, if I hit the play button, this is not our character. You see? This is not the character that we want. Instead, over here, I'm going to right click and blueprint class, and I'm going to filter from game mode or filter for game mode and click here and inherit from game mode. And it's going to be our BP runner or side runner, excuse me, side runner underscore game mode. And let's go over here into the project settings and select the BP side runner game mode, and here instead of the default pawn, I am going to select the BP runner character. And finally, this is going to allow us to have our own character in the game. So if I hit the play button, there you go. If I eject, here he is. Now if I possess him, we have a problem. You see, we don't see the character, we don't see anything. And the reason for that is we can move him. If I don't know if you notice, pay attention where he is currently. If I possess him and if I move like this, I'm moving, and let's try to see where he is now. You see, he almost fell down. So there you go. Okay, so what do we need to do in order for this or to make this work? Well, we need to go back in our C++ class, and over here where it says the tick, so inside of our tick functionality, we need to say our temp position. So temp POS is going to be equal to get actor location. Again, we're getting the actor location. Our temp position.x is going to be equal to, or we're going to subtract from it 850. Like this. And on the Z position, so temp position.z is going to be equal to Z position, so Z position. And last but not least, our side view camera set world location. Over here, we're going to pass the temp position, and there you go. So what this is going to do, it's again going to get the current actor location. The current actor location is basically, well, the actor location, just kidding, but the current location is the location of our own actor, of the character. We are going to then change the X position, so subtract from it 850, and the Z position is going to stay the one that we have over here. And then we're going to set that position to the world location of the camera. So Control-Shift-B in order for us to compile this. And by the way, I'm not going to do that, but you're going to do it. If you want to see the outcome, like if you change this number to -1000, -100, set the Z position over here, I don't know, +500, try it out, see the outcome. That will be, that will be your practice. You will understand more. So if I hit the play button now, there you go. You see, here is our character. He falls down. Look at that. But if he falls down like that, we cannot see him anymore. So that's all there is to it. Anyways, again, hit the play button. We can possess the character. Look at that. We can move over here. We can move over here. That's the point, you see, and he is rotating towards the direction where we are moving. If we move backwards, you see, he rotates to move backwards. If we move forward, he rotates to move forward. There you go. We can press space to jump like that. There you go. But the issue is we only have this one platform. How or what we need to do? Well, we need to create more platforms. It's logic. So starting from the next video, we are going to prepare everything to start creating our level parts. And then we are, of course, going to start encoding all of that so that we can have our level to play the game. If something was not clear in regards to this video, make sure that you ask in the comment down below and I will help you out. And I will see you guys in the next video. Alrighty then, my game dev elves, before we can create our level, we also need to create the obstacles because they are going to be part of the level. So over here in our C++ class, I am going to create a new C++ class and it is going to inherit from the actor. So one is going to be called obstacle. So over here I'm going to say obstacle, and of course wait for Unreal Engine to add it into the project. Again, that SSD is going to arrive on Mondays or Tuesday, because now it's Saturday for me recording this. I'm going to sing to you in the meantime. Thank you very much. That will be $5 extra. Now the bad news is that we need to create another one. So right click over here, new C++ class, and this time an actor again, and this one is going to be spikes. So spikes, there you go. Hit enter, of course, and wait for it to torture us. What else can I say? The good thing is that we are not going to code anything. Instead, we're just going to use these classes so that we can, do a cast later on when we collide with these objects, of course, from the blueprints that we will create. So over here, if I open it, let me just reload everything, reload again. There you go. So we have the spikes, we have the obstacle, but as I said, we are not going to code anything over here. Instead, we're just going to use these as references to create blueprints. So let's go back in our Unreal Engine, and over here into the blueprints, I'm going to right click in new folder and I'm going to call this one obstacles. And inside of the obstacles, I'm going to create a blueprint class. One is going to inherit from the obstacle, which is this bad boy. And I'm going to call it BP obstacle. Simple, very simple. Right click again, blueprint class, and over here one is going to inherit from the spikes, and I'm going to call it BP underscore spikes. Simple. Double click it, open it in our editor over here. Almost said Visual Studio, but it's actually the editor again. So what are we going to do? Well, first things first, for the spikes, I am going to click on this BP spikes and add a static mesh component that I'm simply going to call spike. Very simple. Now for the spike static mesh over here, I'm going to click on the drop down list and filter for our quad pyramid. So I'm going to say quad pyramid. There you go. This is the one that we want. And over here for the materials, I am going to filter for the clay new. And this is the one that we want. There you go. This is pretty much it, except over here, I'm going to set it to -50 on the Z position. So simple as that. And also when it comes to the collision, we are going to do one interesting thing. First things first, I'm going to compile and save this, and I'm going to go here into the project settings, and I'm going to go here into the collision for the project settings. So it's basically this over here under engine. When you go into the project settings, over here, we can create our own object channels. What does that mean? That basically means we can create our own layers to differentiate the collision between actors. So over here, I'm going to click on new object channel, and the name for that one is going to be obstacle, and the obstacle is going to block. So the obstacle is simply going to block the player. It's basically going to be a solid body, not allowing the player to pass through. And that is what a block is. And I'm going to click here, accept. Next over here, I'm going to say new object channel. And this one is going to be our spike, but the spike is going to overlap. The spike is going to overlap so that we can overlap and detect collision between the spike and the player. I'm going to click here, accept. So now we have the block and the overlap channels over here. What does that mean? That means now that I can go inside of the spikes over here and scroll down over here where it says the collision. There you go. This bad boy over here. I can zoom in for you to see. There you go. So over here, the collision preset, I'm going to set that to custom. So click on the drop down list and click here custom from the list. Over here, we are going to have the collision back to query only. So we're going to have query only, no physics collision, because we don't want to collide as a physics object with our pyramid, or basically the spike. And over here for the object type, now we are going to have, so let me just compile and save this. So now we should see the spike and the obstacle, which is the one that we have just created over here. If you don't see it right away, just compile and save for your blueprint, and then here from the object type where it says world dynamic, you can select this one to be spike. And there you go. So over here, I'm going to set our spike to overlap everything except over here the obstacle. I don't want it to overlap the obstacle, and we can also set here not to overlap or simply ignore the camera because we don't need the camera. Compile and save that. So it is going to overlap all of these other responses such as the pawn, physics body, which basically our player, we're going to set him to be a pawn. So this right here will be able to overlap with the player. And of course, then we will detect collision between them and destroy the player and all of that good stuff. So now we can move forward to our cube or to the obstacle, which is this one. And again, from here, static component, we are going to filter for our static mesh, and I'm going to call this one cube or simply call it block obstacle. There you go. Over here for the static mesh, I am going to filter for the cube, so simply type cube, and there you go. Where is the cubey? There you go. Here is the cubey. And over here for the material, I'm going to say basic shape material. This is what I want. Compile and save that. Now I'm going to leave it 0, 0, 0 for X, Y, and Z, and I'm not going to touch the rotation. I mean, there is no point in touching the rotation because it will still be the same. It's a cube. And going back over here, again, for the collision preset, instead of block all dynamic, we are going to set it to custom. Over here, the collision enabled will be query and physics because, again, this obstacle, this block obstacle, it is going to be a solid body, and it is going to block the player when the player collides with it. The player will not be able to pass through it. And over here, for the object type, we're going to set that to be an obstacle. And we are going to set it to block everything except over here, the spike. We don't need it to block the spike. You can simply overlap the spike, but it is going to block everything, meaning it's a solid body. I am simply going to compile and save that, and there you go. So this is pretty much it as a preparation when it comes to creating our level parts. Now, of course, if something was not clear, make sure that you ask in the comment down below. And starting from the next video, we are going to build our level parts and the level and all of the good stuff. Then we're going to start spawning them and yada, yada, yada. So I will see you guys in the next video. What it is, Game Dev Gangster in the house! Moving forward, now we are going to create our levels. And for that, we are going to go inside of our C++ classes and right-click and build a base level class, which is going to inherit from the actor. And I'm going to call this one, so over here, base level, and hit enter to create the class. And of course, we will have to wait a moment or two or a gazillion moments for Unreal Engine to take mercy upon our mortal souls until we wait for that SSD, man. The more you watch these videos, the more ad revenue I get, I guess, and the more faster I can buy that SSD. Just kidding, but let's go over here and reload everything. There you go. Here we have our base level.h, and here we have our base level.cpp. So inside of our .h, the first thing here at the top, right below the includes over here, I'm going to forward declare. So I'm going to say class uBox component. As I said, this is called forward declaration so that we don't have to use the import or include, excuse me. Now going back here at the bottom, right below the public virtual void, I'm going to create protected, and I am going to create a U property. And this U property is going to be blueprint read and write. It is also going to be editable anywhere, so edit anywhere. And last but not least, I'm going to set it under a category, which is going to be equal to triggers, like that. What the hell is this, teacher? I don't know. I'm confused. I want to slap you. Listen, and don't slap me, okay? So what we have over here is blueprint read and write. Basically meaning the component that we now declare, which is going to be a uBox component, which is a pointer. So I need to add a star over here, and I need to call this, or I don't need, but I'm going to call it a trigger, which means that this component trigger can be read and written. We can edit it and we can get a value of it inside of the blueprint. Edit anywhere means we can edit it inside of the blueprint editor, on the side in the details tab. And the category triggers, basically when we search for this component in the blueprint code, we will find it under the triggers category. So we can also call it my triggers, you can call it like that, and we will see that when we search for it. So what I'm going to do is copy this and paste it down below, because we are going to have the same signature, but this time we're not going to call this one trigger, but I'm going to call it spawn location, like that. And last but not least, we're going to have two public functions, so public like that. And what's going to happen here, these functions are going to return a ubox component, which is a pointer. So this one is going to be get trigger, which is going to get our trigger, not trigger, it's trigger. And another one for ubox component, and it is a pointer. So over here I'm going to say get spawn location, like that, and there you go. Now, don't worry if this is still white text, you know, it takes Unreal Engine for this to compile. While we're waiting for that SSD, you get my point. I'm going to right click on this bad boy, quick actions and refactoring. I'm going to create a declaration for it. Over here, do the same thing, quick actions refactoring, create a declaration for it. And of course, I don't know what to say. I mean, you see the issues we all have. So inside of our CPP is where we are going to include, same as what we did with our players. So include, and I'm going to include components / box component.h. It's .h, there you go. And inside of our begin play, I am first going to test if the trigger, if it's not equal to null PTR, meaning null pointer, then I'm going to say trigger, and from here I'm going to say be hidden in game is going to be equal to true, and not allow that trigger to be, you know, visible in the game. Let me just compile all of this so that we make sure that nothing is wrong and that everything should be working, because it's not giving me autocomplete, it's not giving me anything. You see, build succeeded, we're good to go, but you know, it takes Unreal Engine. I will probably have to restart or close my Visual Studio and open it for this to work. I don't know, do not ask me. Over here, we're not going to return a null pointer. Instead, I'm going to return a trigger. And over here, I'm not going to return a null pointer. Instead, I'm going to return a spawn location. That's all there is to it. And again, make sure that you compiled or build this. So it's Control-Shift-B to build this code. And voila, there you go. Of course, another way to build this code is to go here and simply click compile. This is the same exact thing, but I am not going to do that. Otherwise, we will wait a lot. So let's go over here inside of our blueprints and right click and create a new folder. And this one is going to be our levels. Inside of the levels folder, I'm going to right click and create a blueprint class and inherit from the base level. There you go. And select, and I'm going to call this one BP level 1. Of course, we're going to have level 2 up to level 10. And what's going to happen in this one, I'm going to open it and I'm going to create a few levels. And then I'm going to leave up to you to create the other levels, because, you know, this process can be a little bit tedious. It takes a little bit of time and all of the good stuff. The first thing that I'm going to do over here inside of the BP level, I'm going to go and add a few components. The first few are going to be a static mesh. One is going to be a floor. And another one, I'm going to duplicate this bad boy. So copy and paste. And instead of floor, I'm going to call this one cube. There you go. And also I'm going to have two box triggers. So box collision, that is. One I am going to call, and this is not going to be a child of the cube. So I am going to call this one trigger box. Copy and paste it. And this one, I am going to call it spawn location box. Let me just compile and save that. And let me just add everything that I need. And we are going to code, or actually before that, in the event graph, what I'm going to do is remove all of this. And over here, we have in the event begin play, I'm going to set the spawn location. So I'm going to right click over here and I'm going to say set spawn location. And notice it's under my triggers. Look at that. You see this over here? Look at that, my triggers. It's basically what we did in our code. So if I go back over here where we have declared these triggers, look at that. So my triggers, This is that category. So now we can find them under this category inside of our blueprints when we want to code. So I'm going to right click and I'm going to say set spawn location. And the spawn location, again, make sure that it is under my triggers. So set spawn location, here it is under my triggers. And the execution flow is going to go over here. And I'm going to set that, or the spawn location box is going to be the spawn location. Next from there, I'm going to say set trigger. And it's this one over here under my triggers. So the execution flow is going to continue over here, and then I'm going to take the trigger box and plug it in over here, and let me just compile and save that. What this is going to do is going to set the spawn location from our code to this one over here. So we have, connected these two, meaning that now this is a reference to this over here. Same thing that we did over here. Make sure that you compile and save that. So now going inside of our viewport, and here is my floor. What am I going to do to the floor? Well, I'm not going to do anything to the floor because, I'm a good boy. I'm not going to do anything. Instead, what I'm going to do is go over here for the static mesh and filter for the cube. And there you go. Here is our cube. For the material, we are going to say basic shape material. Voila. That's all there is to it. And I am going to change the scale of it. So the scale X is going to be 10. The scale Y is going to be 1, and R, let me just go over here. I have locked the icon, so I don't want to lock anything. But over here, scale X is going to be 10, Y is 1, and Z is 0.5. So this is going to be our floor. Next, we're going to have a cube. So over here, taking the cube, and again, adding a cube to it, and over here, basic shape material, there you go. Now for this cube, I'm going to set it at 90 for the Z position and leave it like that. And that's all there is to it. The trigger box, I'm going to take it. And for the trigger box, I'm going to set that location 380. The location Y is going to be stay at 0, and the location Z 250. And I am also going to set the Z scale to 10 over here for the trigger box. The trigger box is basically going to be the trigger that when we pass through it, then we are going to detect collision, and then we are going to spawn a new level. So this is what we're going to do with the trigger box. So when the player passes here and he touches that collision, then we are going to detect that, and we are going to spawn new level. And over here, just make sure that it is overlap all dynamic, so the collision preset is set to that. Next, we have the spawn location. And the spawn location, what am I going to do with it is simply I am going to reposition it. So I'm going to position it at 1000. And that's all there is to it. So the spawn location, we are going to use its position to position the next level. So when we spawn a new level, it is going to start positioning from here, and basically it's going to form a new level like that. Simple. That's all what we are going to do with the spawn or with the spawn location. So this is our level 1, and just make sure that you compile and save that. If I go over here inside of the gameplay, I'm going to right click and create a new blueprint class. And now you're going to assume that again, I'm going to use the base level, but this time no, instead I'm going to use level 1. And every next level that I create is going to be a child of level 1. So BP level 1, I'm going to select that, and this one's going to be BP level 2. There you go. And I'm simply going to open it. It already has all of these components set up in the event graph. It is going to call the parents begin play, which is going to do all of this. It's going to prepare everything. We don't have to do it again for this blueprint. Very clever, I know. And that's all there is to it. Of course, now we're simply going to add new things to it, and that would be it. For example, the cube that we have over here, I'm going to reposition it. So the X position is going to be minus 330. The Y is going to stay the same, and the Z is going to stay the same. But I'm also going to add new boxes. So I'm going to copy this cube and paste it, and I'm going to call this one cube 2. And for this cube 2, I am going to reposition it. So x is going to be 190, y0, z 130, and I am going to set the z scale at 3 for the z scale. Simple as that. And copy this one, copy and paste. Now we have the cube 3. And for the cube 3, the position x is minus 70, the position y 0, 180 for the z, and set the z scale to 0.3. And voila, compile and save that. So this is our level 2 blueprint. Simple, very, very simple. Going back over here, right clicking. And again, blueprint class. Again, inheriting from level 1. There you go. Not level 2, but level 1. And this one is going to be BP level 3. Again, we have everything prepared. We have our base cube. We have everything here prepared in the event graph. We don't have to do anything, but we are going to change or reposition this cube. So again, minus 330 for the x. Y, I'm not going to touch, and z, I'm not going to touch. So it's going to stay as is, but now I'm going to copy this cube and rename it to cube 2. And this cube 2 is going to be repositioned at 70 for the x, y 0 for 20 on the z-axis, and over here I'm going to say 3 scale for the z. Compile and save that.